Today we're tackling a problem. Given a target string and an array of words, can we form the target string by concatenating some initial sequence of words from the array? It's a straightforward check, but let's find the most efficient way to do it. The problem asks us to determine if a string is a prefix of an array of strings, words. This means it must be exactly equal to the concatenation of the first 0 or more elements of words. We need to return true if it is, and false otherwise. The core challenge is matching against a potentially growing concatenated string. A common first thought for this type of problem is to build up a concatenated string. We can iterate through the words array, appending each word to a new string. After each append, we check if this new concatenated string equals our targets. If it does, we return true. If the concatenated string ever becomes longer than we know it's impossible, so we return false. This approach works, but repeatedly concatenating strings can be inefficient, potentially creating many intermediate string objects. This leads to a time complexity of O and L in the worst case, where N is the number of words and L is the length of and O, L space for the concatenated string. The key insight for optimization is to avoid explicit string concatenation altogether. Instead, we can compare characters directly. We'll maintain a single index, let's call it S-index, which tracks our current position in the target strings. We iterate through the words array. For each word, we then iterate through its characters. For every character in the current word, we compare it against the character at S-index in our target strings. If at any point S-index goes out of bounds for us, or if the characters don't match, we immediately know cannot be formed, so we return false. If the characters match, we increment S-index. After processing an entire word, we check if S-index has reached the end of If it has, it means we've successfully matched all of so we return true. If we finish iterating through all words and haven't found a match, then isn't a prefix and we return false. Let's trace this with I love LeetCode and words as I love LeetCode apples. We start with S-index at 0, first word is I. We compare I from the word with S-index 0, they match. S-index becomes 1, we're done with the first word. S-index is not at the end of, so we continue. Next word is love. We compare L with S-index 1, match. S-index becomes 2. O with 2, match. S-index becomes 3. And so on until E with 4, match. S-index becomes 5, we're done with love. S-index is not at the end of next word is LeetCode. We compare L with S-index 5, match. S-index becomes 6. This continues for all characters of LeetCode. By the end of LeetCode, S-index will be 13. Now S-index is equal to the length of This means we have successfully matched we return true. For our example, I love LeetCode and the words I love LeetCode apples, the result is true. This is because concatenating I love and LeetCode perfectly forms the target strings. You'll spot this pattern when you need to match a sequence of characters from multiple sources against a single target string. It's particularly useful when direct concatenation is expensive, or when you only need to confirm a prefix without building the full string. Think character by character comparison rather than string operations. The time complexity is O, L, where L is the length of the target strings, because we visit each character in at most once. The space complexity is big O of 1, constant time, as we only use a single index variable. This direct comparison technique is a powerful optimization. Try applying this two-pointer pattern to other string matching problems. Don't forget to like and subscribe for more DSA insights.